Hello, fellow computer scientists. Today we're going to talk about an extension of the if and else called the ElseIf. It's for when we have more than two choices. If we have two options, we have the if and the else for true and false. The ElseIf allows us to add intermediate cases. In a separate video, which is entirely optional, I'll talk about the switch statement, which is another way of generalizing when we have several cases to choose from. But again, it's optional for the AP exam, just something to look at in case it interests you. So let's do our usual task. Let's open the demo code for Unit 7, starting with if, else, if. And what we have here is a structure that has many different cases. It's not just if and else. What it does, right? The method we have takes in some string called letter. So the first case, if the letter equals A, we do what's in here. Okay. If it does not, if that's not true, we continue on. We have an else for if it's false. Then we have another condition. Well, maybe it's not equal to A, maybe it's equal to B. Right? We'll check that. If neither of these are true, we continue on. Again, if the one above is false, well, maybe it's equal to C. We have another case. And last but not least, okay, we check to see if it's equal to D, but only if all three of these have become false. And last but not least, this catch-all, if none of the above is true, we have a default, shall we say, of else. Okay. So it does check them in order. If this one is true, right, it will ignore all the other else ifs and elses and just continue on at the bottom of the last brace. If it's false, it checks the next one. If that's false, it checks the next one. And if any of those end up being true, everything below it gets ignored. So we're going to run it 3 times, once with the value A. What's going to happen? Well, this is true. We'll get the value 65. Once with the value C. This will be ignored because it's not true. This will be ignored because it's not true. However, we'll get to this one, and it will be true. It returns the value 67. Last but not least, our poor neglected E. Not true. Not true. Not true. Not true. Everything is false, so we just use that last case. So just to convince ourselves that that's what's going on, we run it. The first case, A is true, we get the first value. Right? We check 2 more for the C, right? And we get this value because that's the one that ends up being true. And last but not least, none of the above. Right? That's what the else case is for. Right? Everything was false, so I get the last case. And we can add as many of these else ifs as we want. Right? If we have 17 different cases, we can have 17 else ifs. Right? And the last else is actually always optional. You can have a catch-all for if everything is false, but you don't need. Just like with an if statement, you don't need an else, but it does come in handy if you need it. You have that option. That will only be activated if everything above is false. Okay. So let's take a look at some SAT scores. Same situation. If, else, if. Okay. So we have 3 cases here. If your SAT score is equal to 2,400, your destination is Harvard. Well, maybe that's not true. That's what the else is for. But if it's greater than 2,200, that looks like you're Princeton bound. Okay. If neither of those are true, well, you can always take the test again. But in any case, we have an if, which is always checked first. If that's not the case, well, maybe this if is true. And we can have as many as we want, and at the end an else to take care of when everything else is false. So we're going to try this with a couple of different values, 2,400. Oh, and remember, when checking for equality, the double equal sign for numbers and the dot equals for strings. We'll try it with 2240 and 1300. So again, we get the first case is true with 2400, so we execute that line of code. It's not true with 2240, but the second condition is true, so we execute that second one. And neither of those are true for the last case. That's when we execute the else code. And again, you can have as many of these else ifs as you want as intermediate cases, and the final else is always optional. Logical operators. Sometimes we want to check more than one condition at once. Maybe we want to allow more than one thing to be true at once. Or maybe we want the opposite of. Maybe we want something to not be true. There are symbols to represent both and, when they both need to be true, or when either of two things can be true, or not, when we want something to not be true. Those are called logical operators, and we have symbols for those. Let's take a look at the logical.java class. All right. So here we have these, what I call pipes. 2 pipes in a row stands for OR. So this is checking to see if the height is greater than 6 or the weight is greater than 150. If either of those are true, either or, then this piece of code will be executed. Then the whole thing is considered true if either one of them is true. Could be both, but doesn't have to be. Okay. The other case we have here, height less than or equal to 6 and weight less than or equal to 150. When we have something joined with and, that means they both have to be true. This and that must be true for the condition to be true. I have a little summary of that here. Again, the double pipe stands for or. Either x or y must be true. Both can be true, but they don't have to. The ampersands stand for and. Both of them must be true, both x and y. And the exclamation point means not. And that reverses everything. It's true if x is false, and false is if x is true. You can think it of opposite of, if you wish. So we're going to try this with a couple of different values. Okay. So first of all, if the height is 4 and the weight is 105, neither of these is true. So this if statement will not be executed. Let's check the else if. Well, the height is indeed less than or equal to 6. The weight is less than or equal to 150. Both of them need to be true. Both of them are true. So this piece of code will be executed. And so with height of 4, weight of 105, this else if is true, we get the literal. Anyway, let's make our friend 7 feet tall. What happens then? Well, the weight is still less than 150, so that's not true, but the height is in fact greater than 6, so this part is true, and since this means or, the entire statement is considered true because one of the two is true. So we compile it, run it with these new values. And this piece of code is considered true because one of these two conditions is true, and that's all you need for an OR. Whether or not this is true doesn't matter. The else if is ignored. If the original if is true, everything below it gets ignored. All the else's and the else ifs doesn't matter. Once we find something that works, that's the one we execute. So again, you run it where one of these two is true. Because it's an OR, it's all considered true. Nested ifs else. You can put ifs inside of ifs. If you do that, it's equivalent, really, to an AND. So for this, for example, if num is greater than 50, we'll only look inside these braces here if that's true. If num is greater than 50, then we'll check to see if it's less than 100. So if that's true, then we'll execute this piece of code. So in order for this to happen, this first if has to be true. We go inside, then that if has to be true. So it's really the same as num greater than 50 and num less than 100, which is why it would work for 75. Let me take a look at the code. Okay, so let's run it here. So if we enter the value 75, okay, what happens? This if is true, so we go inside. This if is true, so we go inside. We execute that piece of code. The second one down here. This if is true because num is 75. This if is true, so we execute this piece of code and ignore anything else. So let's try it with a different value. What do you say? Try it with 45. What do we get? Well, first of all, this if is not true. Num is not greater than 50. So everything here gets ignored. Nothing gets printed out at all. This first if is false. There is no else for that if, so nothing happens. Now let's go down here. If num is greater than 50. That's not true. So we never go inside, we never look at this stuff in here because num is not greater than 50. We do, however, have an else to match that up with. Okay. This if gets matched up to this else. Why is that? Well, it's the way ifs and else are bound. Whenever you have an else, it's attached to the if immediately above it. Right? So this if and else go together. So this else has to match up with this if because that one does not have an else yet. So again, this is not true. We go to the else that matches up with it. Less than 50. That's the value we get. One other case. For you level 6 super geniuses out there, what's going to happen with the value of 60? So for the first step, it's greater than 50, so we go inside. It's less than 100, so we execute that piece of code. Down here, num is greater than 50 because it's 60, so we go inside. Okay, so we look at this piece of code. This if is not true, so we skip over that. And we go to its complement the else and execute that piece of code. That's where greater than 50 and less than 70 came from. And again, since we went inside this else, or this if statement, we ignore this else at the bottom. Right. One more, the dreaded dangling else. Beware of your braces, or that is, be aware of your braces. Use them as much as you can. When in doubt, put braces around things in order to guarantee that it works correctly. So for this one, what happens? Well, num equals 35. So, this first if is true. Okay? If num is greater than 10, okay, we go inside. Okay. But we only print something if num is less than 25? That's not the case. So this inside gets ignored. This else gets ignored because this if was true. So we did what's in here, but there's nothing for us to do, so nothing shows up. Let's try 15. What happens here? Okay. Well, num is greater than 10, so we go inside. And num is less than 25, so we print out the word jump. And since we're inside this if statement, we ignore the else that corresponds with it. How do we know it corresponds? Because of the braces. This else is right below this brace, so it's got to match up with the if that started those braces. So, why is it dangling? Well, let's take out those braces and see how things change. Okay. So, as it says, take the braces off and rerun the program. Okay. So, what happens now? Well, I didn't change the indentation, but I changed the scope of this if. Tell you what, let's compile it and run it, see what happens. All right. So what happens? Well, this if num greater than 10. Well, it is greater than 10, so I go inside, I go to this if statement. Okay. Num is less than 25, so I print out the jump. Okay. Let's go back and make this 35. What happens now? Well, if num is greater than 10, it is, so I go inside. If num is less than 25, well, it's not. So what do? Well, now this else is attached to this if. Because there's no braces to scope off things, this else looks immediately above to the first if it can find, and it's really actually attached to that one. So the indentation really ought to look like that. This if statement and this else are now attached. So we go inside because num is greater than 10. It's not less than 25, so I go to the else, and that's why run prints out. There's also this statement called the switch case. I'll deal with that in a different video. Again, it is optional, so you don't have to learn about it, but it's a way of condensing ifs and else ifs into one big statement. Okay. Have a lovely day. Enjoy your ifs and else ifs, and I'll see you in class.